Good morning, everyone. This is week 7, classwork 18 honors, calculating probabilities using a two-way table. Okay, so this is our second lesson of the unit. We used two-way tables in classwork 17, so if you haven't done that yet, make sure you do 17 first. What we're going to be doing today is calculating probability of a given event using a two-way table. So first we're going to go over what is probability, and then we're going to get into some examples. Okay, so probability is the likelihood that an event will occur. And a probability is always a number, will always be between 0 and 1, okay? So if a probability is 0, there's no chance that the event will occur. If a probability is 1, that's 100%. It's going to happen, 100%, okay? So when we use a probability to calculate frequency, say we have 100 customers that fill out a survey on their favorite ice cream flavor. Based on the results of a survey, the probability that someone likes chocolate best is 0.37%. Oh, sorry. The probability is just 0.37. There's no percentages here. When we survey, how many people surveyed said that they like chocolate best? Okay, so the probability is 0.37. That will convert to 37%, but in order to figure out the frequency, we multiply the sample size times the probability of an event. Okay, so to find the frequency of some event, so the number of people that like chocolate ice cream, we're going to multiply the sample size of 100 times the probability that somebody likes chocolate ice cream. So when we do this, we will get 37 people. Okay, so we are multiplying sample size 100 times the probability 0.37. We get 37 people out of 100 said that they like chocolate ice cream. Okay, let's bring this into our two-way table. All right, so this is a two-way table. Let me read this out loud. Example 1. The school board of Waldo, a rural town in the Midwest, is considering building a new high school primarily funded by local taxes. In addition to asking eligible voters about support for a new high school, data on gender and age group were also recorded. The data from these interviews are summarized below. Okay, so this is a two-way table because there are the two variables. We have the age in years and should our town buy a new high school, so the answer, yes, no, or no answer. They do also have it broken up by male and female, but we're primarily going to be looking at age in years versus what people think. So, question number 1 is, based on the survey, do you think the board should recommend building a new high school? Explain your answer. I want you to pause the video and take a second to think about this. Do you think we should build a new high school based on this data? Okay, so if you pause the video, you should have been looking at the number of yeses versus the number of nos, right? So what we can do here is add up how many people said yes and how many people said no. So if we add up all these numbers, 29 plus 32 plus 53 plus 60 plus 30 plus 36 plus 7 plus 26. We get the frequency of people who said yes as 273, my bad. And the people who said no, 8 plus 6 plus 40 plus 44 plus 44 plus 35 plus 24 plus 29, we get 230. Okay, that's one way to do it. You could have done something else, but we have 273 yeses and 230 nos. So you might have said, yes, the school board should. So I'm going to say yes because more people voted yes than no. But what we can do is convert these into probabilities. So if we go to the entire total, we would need to add up this as well. We get 12 people had no answer, and the total will be 230 plus 273 plus 12. There's 515 total people who were surveyed, and if we calculate the relative frequency, here we would get 0.53 for yeses and 0.44 for no's. And what we know is that the relative frequency can also be expressed as a percentage. So really, 53% of people surveyed, or of the eligible voters, really, said yes, based on this relative frequency here that I got by dividing my total number of yeses by the total number of people surveyed. Okay? So this really relates to what we were doing yesterday, so make sure, or in lesson 17, so make sure that you did that video first or go back to it and review if you need to. Okay. The next question says, an eligible voter is picked at random. If this person is 21 years old, do you think he would indicate that the town should build a high school? Why or why not? So they're using he because that's the default. They really should say they. But we're going to go, anyone who's 21, do you think they would vote for building a high school? Why or why not? Pause, see if you can think about that. Okay, so hopefully you had a second to look at that. And you were looking at, if someone's 21 years old, they're in the category of 18 to 25. So there's 21's between 18 and 25. So a 21-year-old, there's all these people who voted yes and all these people who voted no out of 21-year-olds. Do you think if a random 21-year-old is selected, would they say yes or no? I would think yes. This person would think that the high school should be built because a greater number of people aged 18 to 25 already voted yes than voted no. Okay? So, I'm going to say a random 21-year-old would vote for the high school because there's a greater number, right? There's a greater number of people age 18 to 25 who voted yes. So we would expect, oops, sorry, you can't see that. We would expect any random 21-year-old to vote yes. It would be a lower chance or a lower probability that a random 21-year-old would have voted no. Okay? So let's go ahead and go to the next part, number 3. And I'm going to leave the table up here so you can see it. Number 3 says, it might be helpful to organize the data in a two-way frequency table. Right, so this was really more than two ways, right? We had too many variables. We had 3 variables. So use the given data to complete the following two-way frequency table. Note that the age categories are represented as rows. The possible responses are represented as columns. So what's happening here is we're getting rid of the male or female variable. So we just have 2 variables, age and yes, no, or no answer. So what we're going to do in order to figure out the number of people who were 18 to 25 who voted yes for this box, we would say, okay, the males plus the females who voted yes. So I'm going to do 29 plus 32 here. So if I show my work, 29 plus 32 will equal, what is that? 61. Should be 61. Okay, and I'm going to keep going for every part. So for no, we had in the year, for the age group 18 to 25, no would be 8 plus 6, which will be 14. And no answer would be 0 plus 0, which is 0. And then my total for this row would be 61. plus 14 plus 0, which will be 75. All right, so then we're going to keep going to fill out the rest of this table. I'm going to do it kind of quickly, so if you want to pause and do this on your own, that would be great. Okay, so 53 plus 60 is 113. 40 plus 44 is 84. And 2 plus 4 is 6. This is 90 plus 113 is 203. Okay, we're getting 30 plus 36 is 66. 44 plus 35 is going to be 79. And 2 plus 2 is 4. So that's going to be 149. Because 70 plus 79 is 149. Okay, 7 plus 26 is 33. 24 plus 29 is 53. And 2 plus 0 is 2. So then we get 55 plus 33 is going to be 88. And these should all add up to 515, as we know from before, right? Because we knew our total yeses were 273, our total no's were 230, and our total no answer was 12. So then 75 plus 203 plus 149 plus 88. Perfect, 515, just like we said before. Okay? If I'm going too fast, just pause the video so that you can take a second to breathe. Okay, so we've completed our relative frequency table. Nope, we have completed a frequency table. And now we're going to analyze this data. We do not have a relative frequency table. So these are what we're looking at. A local news service plans to write an article summarizing the survey results. 3 possible headlines for this article are provided below. Is each headline accurate or inaccurate? Support your answer using probabilities calculated on the table above. Okay, so we're going to calculate some probabilities. Headline number 1, Waldo voters likely to support building of a new school. So we're looking at the probability of people who support the new school. So in order to figure that probability out, we're going to say number of yeses over the total number. So this is a relative frequency, and it is going to result in a probability. So I'm going to do 273 divided by 515, and I get 0.53. So does this headline accurate or inaccurate? Is this headline accurate or inaccurate? Waldo voters likely to support building of a new high school. I would say this headline is accurate because 53% of people, or eligible voters, support building a new high school. Based on the probability, 0.53. Okay, headline number 2. Older voters are less likely to support building a new high school. Okay, so let's look at the probability that an older voter supports building a high school. So let's say the sample is now older voters. So maybe we do 66 years and older people, which shows us that 33 out of 88 older people support building a new high school. So let's calculate the probability that someone 66 years or older supports. So I'm doing 33 because that's the yeses over 88 because that's the total number of older voters that I have. And I'm only looking at older voters here. So 33 divided by 88 in my calculator, that's going to be 0.375. So since 0.375 is less than half, and it's less than the total probability that people will support the high school, I would say this is also accurate. So I'm going to say accurate because only 37.5% of older voters, and we're only looking at older than 66, support the new high school. Okay, one more, and then we have one last example. I know these lessons are a little bit longer, but it's a lot of information. It just takes a lot of time, right? Okay, so headline number 3, younger voters are not interested in building a new high school. So if we're talking about younger voters, I think we're talking about the 18 to 25 group. And this, like, when you answer these in the Google document, as long as you're justifying your answer correctly, there's more than one answer, right? So if I say younger voters, let's see, that would be 61 people that are younger are saying yes out of 75 total younger voters. So if I do 61 out of 75, that's the probability that a young voter, or a voter who's under 25, wants the new high school. So 61 divided by 75 is 0.81. So younger voters are not interested in building a new high school. The probability that a younger voter has voted yes is actually 0.81, which is like 81%, right? So that's pretty high. So I'm going to say this headline is not accurate because 81% of younger voters, and we looked at voters 18 to 25, support the new high school. Right? Okay. So we've got one last example, and then you've got some Google, you've got a Google document that's got 2 of these as well to complete for your classwork. And again, of course, if you have any questions, please, please, please text me or reach out to me somehow. All right. Example number 2. Healthcare officials in Milwaukee, Wisconsin were concerned about teenagers with asthma. People with asthma often have difficulty breathing or with normal breathing. In a local research study, researchers collected data on the incidence of asthma among students enrolled in a public high school. Students in the high school completed a survey that was used to begin this research. Part 1. The probability that a randomly selected student at this high school has asthma is 0.193. This probability can be used to calculate the value of one of the cells below, in the table below. Which cell is connected to this probability? Use this probability to calculate the value of the cell. Okay, so what's going on in this table? Let me show you the table. Is they're saying the total number of students is 1,000. Okay, the total is 1,000. Now we have, for number 1, the probability that a randomly selected student has asthma is 0.193. Okay, so if we want to calculate the value of the cell, that's going to be the number of actual students that this probability represents. So remember from our do now, in order to calculate the number of students with asthma is going to be the probability times, so the probability here times the sample size, or the sample size times the probability. Okay, so if I do that multiplication, that means 193 students have asthma. So where's that number going to go in our chart? We're saying this is the number of students that have asthma. Okay? So that would be student that has asthma total. Because we don't know if their household member smokes or nobody in their house smokes. Nobody in the house, right? So that's the total number of students that have asthma in the school. Okay? Based on the probability that a randomly selected student has asthma is 0.193. We use that times the sample size to calculate the number of students that actually have asthma, not just the probability. Okay? All right. Now we're going to do the probability that a randomly selected student has at least one household member who smokes is 0.421. Which cell is connected to this probability? Use this probability to calculate the value of the cell. Okay. So we're talking about one household member who smokes. And they're giving us a probability, and they want to know the value of the cell. So again, this is going to be the number of students with a household member that smokes. So I'm going to say smoking house, just to be shorter. So we're going to do the same thing here. 1,000, because that's our sample size, times the probability, which will, if we use our calculator, will give us 421. So that's the number of students with at least one household member who smokes. So where in the table are we going to put 421? We should be putting that in the total here for at least one household member that smokes, because we don't know the difference between if they have asthma or if they don't have asthma. So I'm going to do 421 right here. Okay. Then we'll do part 3 and part 4. So the probability that a randomly selected student has at least one household member who smokes and has asthma is 0.120. Which cell has this probability? So we're looking for which cell is connected to this probability for someone who has at least one household member who smokes and they have asthma. So we're at one household member that smokes and the student has asthma. So this will be the cell that is connected with that probability. Now I need to calculate. So we're going to say number of students with asthma and smoke in-house is going to be our sample size times our probability, which will equal 120 students when we multiply 0.120 times 1,000. And we said that was this cell, right? Okay. So now what we're asked to do is to complete the rest of the table. So this is where what we did in the previous lesson is going to come in handy, right? We know that certain cells have to add to each other, right? So we know that the total for the column will be here, right? So 120 plus something is 421. Same thing here. 193 plus something is 1,000. So what I can do to find this cell is 1,000 minus 193. And 1,000 minus 193 should be 807. Yeah? 807? Yeah. Okay, so now we know the total number of students that don't have asthma. But we can't calculate these two yet based on 107. We got to calculate what we're looking at. We're trying to figure out which cells can we calculate with the information that we know. So I know that 120 plus something has to be 421. So I can do 421 minus 120, and that should be 301. Okay. And then I know something plus 421 will be 1,000. So I can do 1,000 minus 421, which will be 579, right? 579. 1,000 minus 421 is 579. Good. Okay, and I could continue like that. So I know something plus 301 has to be 807. So I'm going to do 807 minus 301, which will be 506. And I can do this cell either way. I can do something plus 506 equals 579, or something plus 120 equals 193. I'm going to use the smaller numbers. 193 minus 120 equals 73. All right, so we have completed the table using the fact that this total value will be the sum of the values above it, and our row total will be the sum of the rows behind it. Okay? So if you have any questions, please text me. You've got a classwork on a Google form. You should be able to type in it directly, or you can write your answers on a sheet of paper and send me a picture. All right, good luck. I will talk to you later.